So, for the next lesson, we're talking about line graphs, which is sort of like, as I mentioned, sort of like a cousin to the scatter plot. A lot of the same things that you would see on a scatter plot, you'll also see on a line graph, right? But we want to make sure we understand the different types of data that a line graph will represent and interpret the information on a line graph as well as how to construct a line graph, right? Theoretically, we're not actually doing code here. But a line graph is a chart which represents two variables in Cartesian coordinates, right? This is the exact same first sentence as a scatter plot. And the chart is constructed by a series of data points called markers, right? So each of these data points in the scatter plot would be displayed as just that, as a point. But here they're sort of invisible markers. And then between those markers, we will connect straight line segments. The markers aren't always invisible, but typically they are. And we have an example of this. Here we're looking at quarterly earnings per stock share for Johnson and Johnson. Now, I actually happened to pull this random data set when I built this long before the pandemic and any sort of Johnson and Johnson coming to public popularity with the vaccine. But, here we are. We're looking at their earnings. And we have two sets of categorical data, or two sets of data, two categories, two columns from a data frame, you might say. One on the x-axis being time in terms of the year. I do believe there are 4 readings per each year. We just have every 5 years marked here on our x-axis, and then our actual measurement, which is our earnings per share in US dollars on the y-axis. Now, here, right, we certainly could correlate things with time, but in general, we can see that these profits from the 60s to the 80s were increasing per share. And we can see it's also cyclical. There seems to be a time of year where it goes up and a time of year where it goes down. But in general, it's increasing. Now, an important thing to note here is that the x-axis is maybe it would be a column in your data, but I think maybe more accurately would be like some sort of index. It's not actually like a data reading or a data measurement, right? It's just sort of like a title or a label for each data point, right? As to when that reading was taken for the quarterly earnings per share. But the most important thing to note is that on the x-axis, this data is ordinal in nature, right? There is an inherent order to that data, right? And in the case of time, we're starting at lesser times in the past, moving towards, times which are more in the future, or sort of linearly moving forward, right? There's an order to this x-axis, and that's typically what you're going to see on a line graph. It doesn't really make sense to do it otherwise, because what we're largely trying to do is we're trying to look at the way the trends change over some period of time or some period of space. As I mentioned, typically those markers will be individual points. Typically they'll be made so they are invisible, like we saw in our first plot, but you will often see them actually plotted as well. Here we see each one of those quarterly readings for each of the years plotted, and then we just connect the dots with lines, right? And this is a scatter plot, right? Where I have Q1 1970, Q2 1970, Q3 1970, right, on my x-axis. And then on my y-axis, I have the actual value from that, and I've connected them with lines, right? So there is this relationship between the scatter plot and the line graph, right? They're really the same thing. We've just played connect the dots on the line plot. And much like the bar plots, right, there are some different variations that you might typically see. Here we again are looking at some sort of fake sales by region, right? And here we can see in the thousands of dollars based on these 8 months out of the year, the first 8 months out of the year, right? We can see that in general the trends are the same, but there is some variance from region to region when you talk about east, west, and central, right? So we can represent multiple sort of subcategories of the same variable on the same line plot, which can be informative. There are stacked line graphs that fill an area. There's a whole bunch of different variations, but I think, these two or three variations that are described here are sort of the bread and butter of what you're going to use. And, the sort of key thing to look at a line graph is like if I'm looking at the way some trend changed over time, line graph is going to be my first candidate as to which plot I'm going to make to effectively display this quantitative data. So that's it for the line graphs lesson. We only have one more lesson on common plots, and that is the box plot. We talked about it a little bit when we covered the 5-number summary, but we're going to give it its own video, talk about it a little bit in depth, maybe talk about a variation of it. And then we're going to move on from plotting, and we will move straight into set theory, which is largely the basis of probability theory. And probability theory is largely the basis of statistics, particularly inferential statistics, which is really important to us as statisticians, as data scientists. So that's it for this video. Next up, we're talking about box plots, and I look forward to seeing you over there.